My name is Clark Hudson. I'm the Western Lake Erie Basin Project Coordinator for ODA's H2Ohio program. Justin McBride is going to be our main speaker here in just a few minutes, but before Justin comes on, I think is Terry Mesher on at this time?
I sure am, Clark. Wanted to go through and give everybody a quick update on where we're at. I think most of you are familiar with the H2Ohio program. For our part, for ODA's part, the H2Ohio program is really focused on the Western Lake Erie Basin, starting to address the harmful algal blooms as well as the phosphorus load going into Lake Erie. And that's really what our program is designed at. So far, we've been incentivizing 7 cropland management practices focused primarily on row crop production. You can see on the slide here that we've got an enrollment across the Maumee watershed, and those are the 14 counties that are highlighted in green in the lower right-hand corner of your screen. We've got about 920,000 acres currently enrolled across that project area. We've got about 1,600 contracts. That's about 34% of the overall cropland across those 14 counties. And we have somewhere between $35 and $40 million in proposed BMPs across that project area. And then here this past year, we've also enrolled the 10 additional counties that are highlighted in the orange color. Enrollment across those counties is about 620,000 acres. We've got about 800 participants and roughly $22 million in proposed BMPs annually. Really what we're looking at is trying to maximize the amount of practices that we have installed. And you can see for 2021, we had about 1.3 million practice acres. So that's 1 BMP on 1 acre equals a practice acre. Looking ahead, we have nearly 2.3 million practice acres enrolled across the Maumee and about 1.4 million practice acres enrolled across the WLEB expansion area. One of the things that I guess as we look at where we're going with H2Ohio, our focus has been for the past couple of years on the cropland management practices, trying to get those up and off the ground. We are continuing to look at the other practices. We'll talk today about the 2-stage ditches. We'll continue to provide incentives for that effort. And the other thing that ODA is doing right now is we're starting to build the next biennium budget. All of the H2Ohio fundings across all of the departments, EPA, ODNR, as well as ODA, comes through the biennium budget. And we're just starting that process of updating that biennium budget now. It looks, from what we can tell right now, that funding into the next biennium has a lot of support from both the governor and the legislature. So we expect similar numbers coming in the 24-25 budget. But with that said, there's also obviously a long way to go. We've got about just a little under a year-long budget making process until we get to the final results of this. So, Justin, that's my real brief update. I don't know if there's other things that you wanted me to hit real quick. I certainly can, but if not, I'll pass the floor to you.
All right, thanks, Terry. No, I think that did well. That's a good intro on what H2Ohio is generally. We'll go into the more specifics here, which is 2-stage ditches. Let me share my screen. Just a second. Here we go. Okay, so hopefully you can see this first slide I had up before Terry started speaking. Making sure it's going to go here. This is kind of the agenda.
I can see it, Justin.
Okay, thanks, Terry. Well, this is kind of the agenda we're going to go through here real quick. And then once I get through my part, which is the first couple of pieces, I'm going to switch it over to a professor from OSU to help go through some actual design guidance spreadsheets that he's got, as well as some issues they found on previous ditch projects. So I suppose before we get into the meat and potatoes of the program, hopefully most of you on this call has at least heard of a 2-stage ditch and have a general understanding of the concept. Essentially what we're doing is people like to call this a ditch within a ditch. And I don't know if that's exactly true, but basically we take the existing ditches that we typically have in the agricultural setting, which is standard trapezoidal ditches that are sized to carry a certain storm. Okay. They do a good job at that storm, but when you get these smaller flows coming through it throughout the year, which is most of the year, quite frankly, it doesn't do a good job as well as transmitting those downstream. So you get a lot of things like in the Western Lake Erie Basin in particular, you get a lot of sediment accumulation and whatnot. And that's exactly why we have a pretty intense maintenance program up here where we're going around dipping ditches every year. The two-stage ditch is simply, we're going to leave that bottom part of the channel generally, and we're going to pull the top banks back. And what this allows is smaller flows will easily go through that short inset channel. And then anytime when we get any kind of larger flows than normal, they can kind of spill out onto the benches. It kind of act like as sort of an extended floodplain, and you have all kinds of benefits that goes through that. There's a number of things that happen when you implement a two-stage ditch design. Generally, when you have a ditch system that's unstable, you have a lot of bank erosion. Two-stage ditch designs are typically more stable than what the typical trapezoidal design would be. Okay, but there are a lot of other improvements that a two-stage ditch system has over a trapezoidal ditch. Increased capacity, lower velocities, and things of that nature. We'll go through a bunch of that stuff towards the end here, but that's in general what a two-stage ditch is. This program is going to have a couple main goals. Okay. Our goal when we were building this program at ODA was to keep it as simple as possible, use existing infrastructure as much as we can to get ditch improvements out there, and just have a couple overall guidances. And those are simply that whatever project we do through this grant program, the final project, once it's completed, is going to be placed on the county maintenance program. And that is simply just so that we can ensure long-term success of this project. Not that we expect there to be much more maintenance than the existing trapezoidal ditch. In fact, it's probably going to be less typical maintenance, especially when it comes to dipping out. But we just want to ensure that there's no kinds of issues that might occur during construction or things of that nature that just kind of get overlooked and don't get addressed after it's built. So that's the key number one, is that whatever project goes through this grant must be placed on the ditch maintenance program in the county. Okay. And some counties are different. That maintenance program may be with the county engineer, might be with the soil and water conservation districts. It doesn't matter. It's got to be placed on that program. The other one is we want to make sure whatever two-stage ditches we're putting through this program, they're going to meet some sort of regionally accepted design criteria. So in other words, we're not going to accept a ditch application that is simply what's existing out there. No, it doesn't meet a two-stage ditch design by any standards, but they were just trying to fit it in just to get cost share for the ditch construction. So we do want to make sure we're doing the best job as possible to getting these things sized and designed as appropriately as we can. So those are kind of the overarching goals of the program. Everything else was just kind of building out to make sure that we can make this as simple as possible while still getting these out there using the existing petition laws and other ditch improvement methods that we have on the books. When dealing with two-stage ditch design, there's two that's going to be acceptable for this program. The basic one is the two-stage ditch design, which is just what I said earlier. You're digging down to a foot or two below the bottom of the channel, and then you're leaving that bottom down there for a certain width, and then you're pulling the banks back over top of it at a certain height. Okay, so basically you go down here and you pull the banks back and you've got a two-stage ditch. The bottom one is a little bit different. It's the same top width, but instead of leaving the benches at the bottom, you're taking the benches out. So in other words, you're building an oversized trapezoidal design. And you can say, well, we've already got a trapezoidal ditch out there. You're telling us that's not good for water quality. Why are we building an even bigger one? Well, what happens is when you have the oversized trapezoidal ditch, you have a low energy system that likes sediment to drop out on its own accord and build its own benches. And theoretically, if the equations are somewhat accurate, that over time you should get somewhat of a two-stage shape, just like the top picture, after you get those benches being built from sediment that's coming in from up in the watershed. Okay, so both of these are acceptable, and I'm going to go through some design examples later about how the equations are used to size those. For these applications, I'm going to go through the application form here in a second. For this first iteration of the program, like Terry said, it's only applicable in the existing 24 counties that have access to H2Ohio agronomic funds. Once the applications come in, they're going to be reviewed by us ODA staff and approved or denied. And the things that we're going to need as part of the applications, and I'll go through this in a little bit of a second, but ultimately we're going to need things in the application that gives us an idea of exactly where it's going and what kind of a ditch you're going to be building, what kind of design it's going to be, and then what other types of structures and other issues are you going to have that has to be implemented with this project. Okay. There's that same area that we talked about earlier with Terry's presentation. the way the process is going to work is once you turn in the application to us, we're going to go through and do our internal reviews, like I said, and you can see here, there's a couple of things, few things we'll look at as we go through the internal reviews. But once we go through that and we decide that you meet the minimum bar of what we think is acceptable for a two-stage ditch, we'll say, okay, we approve this project. And then we will develop an agreement that you will have to sign with us that basically puts the dollar amounts and all the agreed upon steps in writing, so that we can then reserve funds from the H2Ohio pool internally until the project is built. Then we can reimburse the build amounts or what was asked for, whichever one is less. Okay. So we'll go to the next slide here. If you got my email I sent out yesterday afternoon, for those of you that was on that email chain, you should have a copy of this application form. Okay. So if you have that available, it's probably going to be easier for you to look through it as I go through this stuff. But if not, hopefully you can see on screen. I got the whole sheets here, so you might have to squint if you don't have a screen big enough for this section. First page here, just to cover, important part is down on the bottom. You can see the application period is yesterday through November 30th. If we get to the point where we have a low amount of applications coming in and we get closer to the end, but we hear that there's several on their way, they just haven't been fully developed yet, we may extend that a little bit, but that's going to be at our discretion as needed. Okay. And then any other future program that we have, let's say that this is the 2022 application period. We may have a 2023, we may have two in 2023. This may be the first and only, all those things to come will be at our discretion as well down the future. Okay. First page here, just some general information about H2Ohio. Terry kind of covered most of that stuff, how the money works out. The big one here is in the third paragraph. You can see that we have allocated $5 million for the initial offering of this two-stage ditch grant program. Okay. That's something we'll keep track of internally as we go. Just know that that $5 million could increase, could decrease. The way H2Ohio funding has worked is that there's been some slippage in some of the other programs. And so generally there's a certain amount accessible at any time. So we may be able to go over that $5 million, but right now that was the goal for this first iteration of the program, certainly. Then just below the grant basics, you can see that the first sentence there says this is a reimbursement grant program that provides up to 100%, not exactly 100%, up to. And I'll talk about why you might not get the full 100% if you apply for this. Okay, going to the next page. This is page 3. Part 1. Again, I talked about the two types that are eligible. We'll go in more in those design equations later. Part 2. Projects that would be ineligible for this program. Again, if there's no way it can be placed on the ditch maintenance program in the county, we're not going to consider it acceptable. There may be other grant programs out there, maybe some 319 GLRI grants that are separate from this, that you might be able to get them enrolled in those programs. But for this one, it's got to be on that ditch maintenance program. No questions asked. Then any projects outside the eligible 24 county area. Originally, we had thought about maybe cutting the break off at the watershed border, which cuts through a bunch of the border counties. We decided for ease of implementation and not to worry about that, we'll just go ahead and say that all of the county and all of those that were shown on the screen are going to be eligible. So even if it's outside the watershed, we're still going to consider it eligible. There might be some funding differences about what fund pool it comes from, but that's not anything you guys have to worry about. That'll be internally for us to figure out. Part 3, for the allowable costs for this program, what can you submit to get reimbursement for? First one, obviously staff time. If you have technical assistance for the project, you can certainly record and request all of that. The earthwork, obviously, with the two-stage ditch, as I talked about, you're going to be pulling the banks back. You're going to be making a much wider ditch. There's going to be a lot more earthwork. So obviously that's going to be the big expense of most of these projects. So certainly that would be costs we can reimburse. Structures and appurtenances. So specifically the types of structures I'm talking about is any kind of side inlets into ditches to protect from erosion, any kind of rock protection for a tile outlet or some sort of a tile structure to get it to inlet onto the benches, anything that is required to make the two-stage ditch work. What's going to be eligible. Bank armoring on like a corner or a turn, anything like that, that's going to be eligible for reimbursement. The big thing that's not eligible, really the only thing that we've definitely said is not eligible for reimbursement is going to be bridges and other crossings. We don't want this to turn into a cost share program where you're applying for 100 feet of ditch, but you're getting a $200,000 bridge installed as part of the grant. That's not the purpose of this grant. So any of those types of structures are going to be on your own through the normal assessments to the watershed. Okay, that's like the one thing we can't cost share on for sure. Seeding is also eligible. So whatever kind of seeding you like to do. Some people like to seed the benches, and we'll get into this in a little bit, but they like to seed with a cool season mixture, just a typical type of mix we would do for a grass waterway or any kind of erosion protection. Others like to do maybe like a warm season native grass planting. That's eligible as well. So, okay, page 4. Couple things here in that first paragraph. There's one sentence that says ODA is not responsible for future maintenance costs. I'm sorry, let me skip ahead here. There we go. Is not responsible for future maintenance costs as required by the established county maintenance program. So the idea is once this project is completed, once you've been reimbursed, it is entirely the county's baby. We have no more strings attached to it, which is good both ways, right? So there's nothing we can tell you later on that you have to do, but also there's nothing later on that you can come to us and say that, well, this is ODA's project, you should have to fix it, ODA, and that's not going to be the case. Once we've reimbursed, it's a clean sever. It is now the county's ditch and their responsibility to take care of. Part B under section 4 here is eligible applicants. Again, the only people eligible for this program are going to be the Soil and Water Conservation District and the county engineer for each county. Okay, some counties have soil and water districts that do ditch petition projects, and this will be right into their program. Others do not have that. And so those counties may have a struggle to go through the standard 940 process. And so in those cases, you may want to work with the county engineer to maybe put the application through them, but you can still work with them to provide support and things of that nature. So private landowners are not eligible, not directly. Okay, so these are going to be multi-landowner projects. Obviously, that's why we're trying to target most of the petition projects going through here. You will probably have some landowners coming in and say, I hear there's a new program for 2-stage ditches. I want to apply. That's not how this is going to go. You're going to say, well, thank you for your interest. We can look at your ditch. If it's not currently on maintenance, we can consider petitioning it or maybe doing a group project, private project. As long as it can get put on the county maintenance program when it's done, it would be eligible. But certainly the private landowners themselves cannot apply for it. It would have to go through the county engineer or through the district office. Okay. Going on to page 5 here, project evaluation. I'm not going to go through all those. You can list them there. You can read through them. But basically, internally, we're going to look at all of these factors to try to rank internally one versus the other if we get to that point. But more than anything, we just want to look at these items to make sure it's meeting the minimum bar, to make sure we're not getting into situations where we're installing a 2-stage ditch on a very steep grade or in an inappropriate area, things of that nature. We just want to double check everything to make sure it makes sense as we go in there. If we do get to the point where we're running thick on projects and thin on money, we may start ranking one versus the other and use some of these items as sort of those cutting measures to separate them. But we have to get to that bridge before we can cross it. I'll be honest with you, this is going to be the first iteration of this program. So a lot of what this is going to happen internally is going to be sort of building the car down the road as we drive. Unfortunately, we didn't really have anything to model this off of, so we're going to have to basically take care of the hiccups as they come. Hopefully it goes pretty smoothly the way we've set it up, but certainly I'm expecting some unforeseen issues. Just hopefully they're not major issues. All right, frequently asked questions section in the application form. I'll hit some of these. You can read through all of these. And if you have any other questions outside of this, you can put them in the chat bar and I can address them once we're done here, or you can send me an email sometime later and we can take care of it at that point. Second one here, can I make changes to my project after it has been selected for funding? The idea is we want to make judgments on your application based on the merit as you present it. So if you're trying to apply for a ditch and you want to sign up the entire ditch stream, knowing that you're not going to do that up front, those are the type of situation we're trying to avoid. If you honestly apply, you think you can do a whole section of a ditch, and you have good intent, we can talk about changes to that down the road. there's going to be a lot of back and forth during the application process. They're going to come into me, and then a few of us engineers are going to review it, and we may have some conversations back and forth between us and you to determine what other kind of changes might be needed before we finalize everything in the agreement form that's yet to come. So just keep that in mind. We want to keep them as close to the application as you did it, but changes do happen, and we are flexible to work with them when we can. Just down the list here, one of them, how long do I have to complete the project? So we're hoping that we can set a deadline at the end of 2024. And what that would give you is all of 2023 to construct the ditch project and all of 2024. So 2 construction seasons to get these projects completed. If it's going to stretch out longer than that, then we may have to talk about other things, what we can do. That ending date isn't necessarily that's absolutely when it's going to be. We might be able to extend some construction projects, but that is something we're trying to shoot for with these applications, is to have everything done by the end of 2024. Just below that, will prevailing wage laws apply to ditch construction paid for via H2Ohio grants? So those of you who run the petition programs and ditch construction in your counties will know that generally projects under the 940 process and 6131 are not classified as public improvements unless, and this is, as you go through there, you can read, and the one thing that's going to get us here is 75% or more of the cost is paid via private landowner. So if it meets that, it's not a public improvement. But if it doesn't meet that, then it is a public improvement, and the state prevailing wage laws do apply to the project. And since this is going to be a grant funded by state dollars, that means nearly all of it's going to be publicly funded, and it will apply to the prevailing wage laws. And I know that's going to be a little bit different for those of you, particularly the districts who do this ditch work, is you may not use those wage rates very often, but the county engineers should use, like on several road projects and whatnot, it's probably not going to be totally unknown. You should have a prevailing wage rate coordinator somewhere in the county, whether it's with the county engineer or elsewhere. They can kind of help you with those cost estimates for those wages. But just know that that's on you. These projects are going to be wholly your projects, just like any other petition projects. It's going to be your responsibility to get them done and put together the estimates and make sure all the appropriate laws and permits are going to be followed. Okay. All right, let's go to page 7. What additional management is required on 2-stage ditches beyond normal ditch? We'll talk about this a little bit later, but there's not really a whole lot more that's expected. If you're currently spraying the ditches for noxious weeds and things of that nature, you'll probably continue to do that on 2-stage ditches. We're certainly expecting less sediment to accumulate in these ditches just by the nature of their design. But there may be some additional spraying. You can design entrances to get down to the benches if you want to mow the benches and things of that nature. There are things that you can do. So certainly keep that in mind, that the maintenance may be a little bit different than a typical trapezoidal ditch, but we're hoping it's going to be less overall. So are all sections of the ditch project required to be 2-stage? Absolutely not. If you have a ditch project that's a couple miles long and you can only really fit, based on the local landowner who's there, you can only get in maybe 3,000 feet of those 2 miles, then that's totally fine. Just know that we can only pay for the reimbursement for the sections which are actually constructed to 2-stage ditch. So certainly flexible there. What if the H2Ohio grant doesn't pay for 100%? That's where your normal watershed assessments for a petition project would come into play. So whatever's extra, whatever's needed, certainly use those methods to get the funds that are required to finish the project. Does ODA pay for the additional top width easement needed for a 2-stage ditch? So as we'll get into, obviously, if you don't know, 2-stage ditches do require wider top widths overall, typically. And so that's ultimately one of the complaints, one of the resistances from farmers, is that they don't want to give up that much land, or that much additional land, I should say. And while we're not putting that outright in the application form, certainly if a county engineer feels that it's appropriate to pay a landowner for taking their farm ground, whatever ground, away from them, they can put that certainly in the cost request for this application, but it's not required. So it's going to be at the discretion of the applicant to decide whether or not they want to pay for easement access, or even taking away productive land rights. That is totally up to you, and you can include that in the cost. But Everything else being equal, one project versus the other will probably take the lower cost project. So just keep that in mind that it may count against you, but probably not, at least for this first iteration. At the very bottom, what if the ditch has an existing CRP buffer or other easement along the top bank, which cannot be easily moved? We anticipate this to be a major hurdle on most of these. CRP is a big program up here in this area of the world. Most of the ditches have some sort of buffer on them, and a lot of those buffers are enrolled in a CRP program with the FSA office. What we're suggesting is you strongly work with NRCS and FSA to determine where those CRP buffers are and to see if you can work with that office and the landowners to move those easements. Some counties may allow it, some may not. There's nothing we can control with that. That's going to be up to you as the applicant to figure that out. So certainly work with those partners as much as you can to avoid something down the road that you didn't expect, because I do expect that's going to be an issue on a lot of these ditch projects. Okay, page 8, H2Ohio two-stage ditch projects application process and timeline. So just know that during this application period from now to the end of November, we're going to be receiving applications. We're going to be looking through those applications during that window. And if we think projects meet the minimum bar, we will try to get agreement forms put together as soon as we can to get those signed. So there may well be projects that have signed agreement forms for funding before the end of the year. And that would be ideal, but certainly as long as the application comes in before the end of November, then all those can be weighted together. The agreement deadline we've set for the end of the year, December 30th. So theoretically, if we get an application at the end of November, that'll give us 30 days to put together an agreement form for that project if it becomes approved. So that's that may be a flexible deadline depending on what our kickback is for how long it takes us to get those agreement forms put together. But we did put a date on there, just FYI. The implementation for the construction, again, you have until the end of 2024 for all these projects that get approved. Project completion being at the bare minimum of December 30th, 2024. And as soon as the project's completed, as soon as we have bills that we can verify in, then we can release funds to the project. So it doesn't have to wait until the end of the year, but you can certainly go up to that time. Okay, page 10. We have the application form number 1. This is 2 pages here. The first page is some general information, basically who you are. Page 2 of form 1, you can see a little more information on the project itself. What's the ditch name that's used there? What's the HUC 12 that it goes into if it's not the whole HUC 12? And then what type of design you want to do, the standard 2-stage or self-forming, which again, we'll go through. Where's it at and the total request funding. You can see I've broken down some project details, how you're going to break down the timelines. This first part here is going to be instrumental for us to review internally. So make sure you fill those parts out. And then same for the bottom part here. That's something we're going to be looking at internally as we go through the review. So we want all of that filled out as best you can. And any additional information you want to add to it is also okay. Form number 2 has to do with a lot of the cost reimbursements that you're applying for. I'm not going to go through all those again. We talked about what's eligible and what's not, but basically we want a good breakdown of how this money is going to be used, and just to make sure that we're not approving some cost share reimbursement funds being held back for things that we don't agree with. So try to be as detailed as possible. You don't necessarily have to use this table that's in the spreadsheet. If you want to make your own and attach it to the application as an addendum, totally fine. But this just gives you an idea of what we're kind of looking for as far as the breakdown of the budget, where the money is going to go and what it's going to be used for. So Form 3 gives us a little bit of information on what kind of method we're going to use to size the ditch. So some of you may have alternative methods to size 2-stage ditches because you've done it in the past, and that's totally fine. We just want some backing information to say, okay, let's make sure we can sort of validate that method that you're using to make sure that it's appropriate for 2-stage ditch design. So just give us a little more information about if you're going outside of the norm on the design, why you're doing it, and what kind of documentation you can use to support that it's going to work. Okay. Second question there, what kind of permits? Again, I just want to reiterate, once you're approved for funding, this project is your baby to get it all done. So whatever kind of permits are required from Army Corps, EPA, it doesn't matter. It's the same for any other ditch project that you do in the county. If you're required for permits, then make sure you get them for this project as well. Form 4 is probably the most controversial questioning form, certainly for myself here. We kind of put it together, kind of doing some forward thinking. This is probably the one form that you're not going to need to submit with the application in most cases. What we were kind of thinking is we would use this as sort of a document that the soil and water districts could give to their board to say the board has seen the project, they approve that the district has the ability to apply for it, and whoever within the district is given permission to act as the project lead. Again, I don't anticipate this form being used. If you don't turn it in, that's probably the one that we won't hit you on so hard. So just know that it's also an example. These last two forms are examples of what you can use. If your county prosecutor uses something different, that's totally fine. But certainly on this form 5, when we get to this one here, this is going to be something we will require. And what we really need, you can use this, you can use your own type of thing, that's fine. We just need something from you that the county commissioners are giving us a guarantee, or the best guarantee they can, that once this project gets completed, it will be placed on the maintenance program. Okay. That way, when we reserve the funds and they're sitting there for a year or 2 years, that they will finally go out and we don't get to into this project and county commissioners decide they don't want it on the maintenance program for whatever reason. And then we're sitting there with a bunch of money and the project didn't get funded. And that's a failure that we're not looking forwards to. So all you can do to get the county commissioner commitment up front will be great. So, okay. The last part of the application form is the plan map and the design method. So this is where you're going to submit the stuff as an addendum, where it is, plan maps, where things are going, what kind of structures are being used. These don't have to be engineering plans. I want to stress this. During this application period, you do not need finished signed engineering plans. Okay, that's to come later. But you can put together a plan map showing us where things go and the estimated top widths, things of those natures, what kind of watershed boundary it is, all that kind of stuff listed there. Give us a plan map that shows all that so we can kind of see exactly what's planned to happen. Okay. All right. Down at the bottom, the changes in the plans, we talked about that. We hope that there's not many changes, but certainly if there is, we can work with you through that process. Okay. You can read through here through the steps to complete the project. I'm not going to go through this because it's pretty self-sufficient in wording here. You can read. Page 18, grant application checklist. Just a helpful checklist. Make sure you have forms 1, 2, 3, and 5, with 4 being optional. I know it's not written on there, but if you want to keep this in mind, 4 is optional for now. Perhaps in future programs, future iterations of this, we may require that, a different version of that, who knows? But we did put that together just in case you wanted to use it. So, and then the very last checkpoint is when you send these applications to me, try to put it all into one PDF file. That way I can store it all as one PDF file and I don't have to refer to a bunch of other files whenever I pull yours up to review it. So anything you can do to put it all into one single PDF file would be fantastic for me. So that's just be helpful. All right, it is 2:05 and I believe I'm right on schedule for the next topic. Clark, do you see any quick questions in the chat before we go on?
No, not at this time. There are no questions in the chat box.
Okay, so we'll go through this next section. If there are questions, go ahead and put them in there. There should be time towards the end. If we run late on this webinar, we can keep going. Those of you that have to take off, that's not a problem. This will continue to be recorded. We'll keep going for now, but certainly feel free to ask questions as they come through. Okay, so now let's get to the actual, this is sort of a training part of the webinar. That first part was more, this is the program, this is the application that we want you to use, and then good luck. This part's going to be more, okay, if you're going to do a 2-stage ditch design, how are you normally going to do it? And so generally the way we see it is typically most people will like to use the regional curve design method. Okay, there are other ways to do this, and you'll get to hear from another way after this one, but most of them use this method. So these tri-state, these agricultural ditches regional curves were put together by OSU And they do a fairly decent job of representing the types of watersheds we deal with in Northwest Ohio. And that's why we tend to gravitate towards these equations to use in two-stage ditch design. And it's quite simply, there's two equations. There is the width equals 6.9 times drainage area in square miles to the power of 0.42 for the width, and for the depth, it's just the drainage area to the power of 0.32. Again, those are both in square miles. I didn't put that on the slide. I probably should have done that. My bad. But those two, the width and depth, what those represent, and I'll talk about this a little bit more, is the width and depth of the inset channel, the smaller channel within the bigger channel, if you want to think of it that way. The width is the top width of the smaller inset channel, and then the depth is simply the depth of that inset channel. Okay. From there, you can use a couple other factors to figure out the overall top width of the whole thing. Okay. So typically that's what those equations will give you. Then after you calculate both of those based on the drainage area coming through the ditch, you want to figure out what your floodplain width is above the inset channel, the total bench width. Okay. And so that full width is simply 3 to 5 times the top width of the inset channel. So if the inset channel is 5 foot wide and you wanted to do a 4-to-1 floodplain width ratio, then that total bench width all the way across there would be 4 times 5. So that'd be 20 feet total across the bench. And I have an example we'll go through to kind of explain that a little bit more. So from there, you just need to get your banks on the outsides of those to come up to the side, and that's simply 2-to-1 minimum. You can do 3-to-1 if you want even flatter slopes, whatever you're comfortable with. But from that point on the bench out, you're just going up on a 2-to-1 slope. Okay. So fairly easy equation to use. All you really need to know is the drainage area coming through it. This doesn't take into account the grade of the channel, none of that stuff. All we're saying is that based on a certain area that's out there, a contributing watershed, that this is generally the size of the inset channel. That's what you're using with these equations to figure out the size of that inset channel. Everything from there can be found out by picking your floodplain width ratio. Okay. Couple things to note when you use those equations. The benches, even though that I've showed them here to be the same width on both sides of the inset channel, they don't need to be all the same size. We would just prefer that it's not totally one-sided construction. There have been one-sided constructions, but typically that's where more failure is expected, not necessarily guaranteed. So we do like a little bit of bench on at least both sides if possible. Okay, so but it's not like you have to have the inset channel right in the middle of the benches. It can be offset a little bit to one side or the other. The current channel size, so the ditch that you're going to be out there when you first do your first survey of the site is likely to be different from the inset channel, and that's going to be a given, right? We're going to use an equation to come up with a size. It's a high likelihood that the bottom width of the existing channel that's out there is going to be different than what we calculate with the equations, and that's not a problem. We can talk about how to adjust to that. Flooded width sizes are guidelines and can be adjusted by 25%. Again, there isn't anything set in stone here. Whoops. If we have to fluctuate a little bit, totally fine with in the designs. As long as we got the benches that are out there doing their jobs, a little bit wider is not a big deal. The depth, typically the shallower the better. So if you're going on those equations to calculate the depth of the inset channel and it comes up to like 1.33, then typically you want to round down to 1.3. That's okay. You generally don't want to go deeper than what those equations suggest. Okay, so we can use those same two equations for the two-stage ditch for the inset channel, and we can rearrange them with a couple of assumptions to calculate the bottom width of the oversized trapezoidal channel, the self-forming ditch as we call it here. So just by doing some algebra, you can rearrange them. You can choose floodplain widths. You can come up with 3 different equations based on the floodplain width here. And ultimately what these equations give you, if you pick one to use, these give you the bottom width. If you can see my mouse here, the bottom width of this oversized channel. And from there, you have your design grade and elevation. You can just go a 2-to-1 slope to get to existing ground. Okay. So probably pretty easy to design, pretty easy to construct. It's just a lot of dirt to get to that point. Okay. Okay. Let's do a quick example. I have a given watershed size of 2.46 square miles. The grade for the section that we're in is going to be 0.1%. 0.1% grade. The existing ditch, or you can think of this if we were going to do a typical ditch dip out and build a standard standard trapezoidal shape, is going to be 8-foot bottom width, 5-foot depth, 2-to-1 side slope, which makes a 28-foot top width. That's the footprint of the typical trapezoidal ditch we would do in this sort of general scenario. When you plug all those into the equations, then the existing bankful capacity is 218 CFS. What does that mean? Okay, for the watershed that I picked, and again, this is something I just put together this morning, but for that watershed, and there's a lot of assumptions for the watershed. This is in Hardin County with a curve number of 85, standard watershed slope of 2%, and a watershed length of 2.52 miles. Your projects could be vastly different than this. You might be in the Great Black Swamp area and in maybe Henry County, and you have an average watershed slope of 0.5%. That's going to drastically change the data up top, obviously. So, but this is just what I picked for this example. So I've got some flow rates here for this watershed. You can see the QB flow, which is the Soil Conservation Service drainage curve for excellent drainage. If you're a county engineer and you're not familiar with QB or QA, it's something that we use in the district world quite often. But typically when we teach ditch design, we want to meet at least a QB flow. Okay, at least a QB flow. And that's exactly what the ditch does, is it gets us somewhere between a QB and a QA flow, which is pretty common for the ditch work that I've seen up here in Northwest Ohio, somewhere between the two. Occasionally we can get ditch capacities that can haul up to the 10-year storm, which in this case is 1,000 CFS, but on a watershed slope of 2%, that's pretty rare to do. It usually takes flatter slopes than that to be able to get a 10-year storm to fit in a ditch capacity. So just keep those in mind. We'll go through this example as those understanding. But right now, this existing condition is we can only drain somewhere between a QB and a QA flow. All right. So if we apply the two-stage ditch design equations to this, we come up with the inset channel width of 10.1 feet and a depth of 1.3 feet using those same equations. Okay, we plugged in the 2.46 square mile area, and that's what we come up with. We chose that we wanted a floodplain ratio of 4:1, which means we simply take the width of the inset channel and we times that by roughly 4. And so that'd be 40.4. In this case, to make things simple, I just made that bench width 40 feet. Okay, so there's a little bit of flexibility here. You don't have to pick exactly the 10th decimal type of things, because we're still going to have pretty good benches out there. So I chose 40 feet for the bench width, and then you can do some algebra and some basic geometry and come up with the overall top width of the finished two-stage ditch to be 54.8 feet. And then if you're familiar with the Manning's equations and the continuity equations, you can figure out the bankful capacity is now for the same grade, 452 CFS for that same area. Instead of doing a standard trapezoidal ditch, we are now doing two-stage, and we can carry twice the amount of flow, which if you know anything about those equations, you know that when you increase the cross-section area, obviously you're going to increase the capacity. So if we then apply the self-forming design, which again is the same thing as a two-stage ditch, except that you're taking out the benches. You're building an over-wide trapezoidal channel, and we pick that same 4:1 floodplain ratio, what we'd like to see, just to get an idea for apples to apples. Then we come up with a bottom width for the overside channel of 34.9. There's a little bit of some rounding error in this, and so that makes the final top width 54.9 as opposed to 54.8 for the two-stage ditch. So it's exactly the same. And then because you took out those benches, you obviously have additional cross-sectional area. We can carry a lot more capacity. So in this case, 655 CFS. And if you compare those three, the existing trapezoidal ditch up here to the two-stage ditch to the self-forming design, you can see the differences in the top width. Obviously, they're going to be the same for the two-stage and self-forming in most cases, but you can see that both of them are about twice as wide as what the existing trapezoidal design would have given us. But then they also have 2 or 3 times as much capacity. And so when you hear people say that two-stage ditches help reduce flooding, certainly when you're going from a QB flow that floods frequently to where you can carry a Q1 storm for a 1-year storm event without overtopping, or even a 3-year storm event without overtopping, you're going to reduce some flooding. Now, obviously, you're still going to have some areas are going to have much bigger storms than a 3-year storm. And so you might still have some flooding, but that sort of likelihood is a lot less. The impact is a lot less. Okay. And then here I put down some estimated earthworks. Those are just the difference in areas between them and the existing ditch, trapezoidal ditch. So you can obviously see that for every foot of the ditch you're going to construct to a self-forming ditch, you're going to be taking out at least 5 cubic yards of dirt. And so it's from there you can start to put together an estimate on your earthwork as you go through there. Over time, the self-forming design, the overwide design, it's going to build its own benches like I talked about. And so over time, this capacity is going to reduce as those benches are built to closer to this capacity of the 2-stage ditch. Okay. Now that may take 10 years, 20 years, 30 years, may never happen. It just depends on each situation, but there is going to be a drawdown on the capacity of the self-forming ditch to eventually equilibrium state should be around the 2-stage ditch design. Okay. Okay. I just drew this about an hour ago, so I know there's sort of lines going everywhere, but the standard trapezoidal ditch design here, again, 5-foot depth going across here, 8-foot bottom width in the black, and then a standard 2-to-1 side slope. Obviously, you can see the increase of top width to get to both the 2-stage and the overwide design. And depending on which one you choose, the benches, if you do the 2-stage ditch design in blue, you would leave a bench of 1.3 foot deep to this width, and then you would remove this 3.7 foot depth out to this bank width. But if you were to do the overwide design, you would just go ahead and dig all the way down to the bottom to the grade and get a bottom width here of 38.4 feet, and then just build your standard trapezoidal side slope and let the benches build over time, like I said. And you can see that there's going to be a situation here where the design bench is actually inside of what's existing. So obviously we can't build earth inside of what was already out there, or at least that's not ideal. So it's perfectly fine if you run into this kind of a situation to not construct these benches out to this defined top width. So in other words, you can leave the top width of the inset channel to, let's say in this case, this was actually 15 feet to get from this point to that point over there. That's totally fine. It doesn't have to be 10 foot wide exactly, but you can just make it fit to what you have. Okay. So hopefully that's not too confusing. That's something we can maybe clear up with you as you go through the designs, but that's kind of the idea of how this all works.
Justin, you do have 2 questions in the chat box. The first question is, can a county apply for more than one project?
Yes. That's an easy one. Yes.
Okay. Question number 2, from Megan in Crawford County. Who approves the final site construction approval, ODA or the county engineer's office?
Final site construction approval is the county engineer's office or the district, whichever one's taking care of the project. It is the payment that they're looking for, I assume is the question, who approves the payment. That payment approval will be a review from the engineer's ODA after the finished construction project, just to make sure that the quantities line up with what was actually built. So in other words, when we sign off on something at the end at the ODA level, we're not signing off on the actual design and construction of the project. What we're signing off on is the payment that's approved for the project. Okay. Hopefully that makes sense.
Yeah, hopefully, Megan, that answers your question. If not, we have a question. How many years is this funding going to be available for?
That's a question for you, Clark.
Well, as Justin said, we've got $5 million worth of funding for this year. After we get this first round of applications, we'll take a look, and if there's still a lot more projects that could be done, we'll be looking for additional funding for in the next budget year and so on and so forth. If this is a popular practice and we can get a lot of these done, we have funds. Hopefully we'll have funds available to continue to develop these through the next several years.
I think that's about the right answer. Is this is a successful program at first and people are enjoying it, and we're getting a lot of successes out there that it's a likelihood that we'll keep offering it. So
Hey, Clark, Justin, if I may, on that question specifically.
Mhm.
All the funds that we got for H2Ohio are coming through the biennium budget. So it's not like H2Ohio has any long-term funding at this point in time. There are some efforts underway to create that long-term funding, but all of the funding that we have is based on the biennium budget. So we can look forward until the end of the biennium budget, and then it's left to the budget process. So Based on what in addition to what Clark and Justin have said, is it really depends on the next biennium budget, how those budgets look as well. If we start to lose some of the support for H2Ohio in the biennium budget, then we'll look to use our carryover. But I think we'll continue this effort as long as we have funding coming in from the biennium budget. So sorry about that. Just wanted to make those complete answers we could.
Thanks, Terry. We'll just go through this last slide right here for the contacts for this program. If you have any questions on the program, the application form, things of those nature, contact any of the first three. Myself, Nate and Tim are both engineers with ODA. We're all in Findlay, Ohio, and we're who the first sort of team of people going to be taking any applications, looking through them. So if you have questions over that process, you can contact any of us three. If you have complaints against me, you can contact Clark Hudson. He's right there. That's what I tell everyone. They can call him for complaints against me. But no, if there's any opportunity for any H2Ohio outreach, any sort of a coordinated effect with the other programs with ODNR, EPA, or even agronomic practices, or you want to come in to kind of meet and greet with the board members or the county commissioner to kind of talk about things, that's certainly where those contacts should go, is to Clark. If you got any suggestions over future programs, different ideas, certainly that kind of stuff can go to Clark as well. So he kind of keeps all that stuff organized. And then if you have any specific design questions, if you're running into issues when you're trying to implement the design on a ditch and you run into, well, I'm not really sure how to armor the bank and what's the suggested, or what kind of bench heights should I do when I have a base flow of a significant amount, things of those natures, you can ask John or Jessica. So hopefully you can get their contact information here. I will send this PowerPoint out to the group, by the way, so that you have all these slides as well. So that's all I had. I know I'm over time. I'm about 10 minutes over what I had planned. Clark, was there any more follow-up questions before we go on to John?
Yeah, Justin, we have two more questions. Oh, now there's a big long question. So let me read it. Are ditches currently on county maintenance eligible? And we said yes to that already, right?
That's correct.
The second question is, maintenance funds are normally based on construction cost and assessments. Any insight on how maintenance would be funded through this grant?
I'm not sure how the legal process works, but certainly there's going to be an overall cost estimate for the project. It's a matter of what was actually assessed to the watershed. So I could see this being a method of where you come up with the total construction cost of the project and put that as the base amount for the maintained amount. But certainly you'd have to check with your prosecutor or someone else in the office who's aware of how that process works to double check that answer. But that's how I would kind of see it, is you would update it based on the construction cost, not necessarily the assessment to the watershed. And on that first question, some of the if there are ditches currently on maintenance that are interested, that's totally fine. You just want to make sure that to move the easement boundaries on an existing maintained ditch may require an entirely new petition process. Again, I'm not as familiar with that, what it takes to move the boundaries of an existing maintenance easement boundary. Talk with the prosecutor, talk with people in the county who know that answer, but just know that to do a wider top width of a ditch on an existing maintained project may require an additional process. So,
hey, Justin,
yeah,
if
go
I
ahead,
may,
Terry.
to Jason's question, I think the point that you made earlier is that once the project is constructed, the state will stand no more liability. And I guess just want to make clear to everybody that as far as the maintenance assessments on these projects going into the future, that's going to be assessed back to the benefactors or the folks that are in the county. That the state is not going to be assessed for future maintenance of the project. So I don't know if there's some specifics within Ohio Revised Code that we got to look at, but we want to make sure that that's clearly understood, that maintenance will be assessed across the benefited acres, and it's not going to come back to the state of Ohio.
Okay. Thanks, Terry.
All right. Two more questions. Have you had any conversations with USACE about this program? Mm-hmm. We have roadside ditches currently on ditch maintenance where we would be interested in making this change, but we could not make a bench along the road. We would need to fill the existing ditch in and construct a new overwide away from the road. USACE has said the past they would not approve this type of construction without stream mitigation.
So yes, I have had discussions with them. on this specific subject, actually. And like all good agencies of the government, when you ask them, is that always the case? The answer is it depends. So in some cases, there are going to be ditches that are going to be considered under the jurisdiction of the Army Corps through the Clean Water Act. Whether or not that's the case depends on each ditch entirely as it's judged on its own. So when I asked the question, so do you want us to send every project that we're doing to the Army Corps? The answer was no, we don't want that. And so it's kind of like we have to decide which ones are going to be applicable towards the Army Corps permits. And so that's going to be on your onus to figure that out. In this specific case, I think you were physically moving the ditch to the side a little bit. And so you're adding fill inside of an existing ditch cross section. And I think that's where the permits come into play. But again, that was only because it was an existing stream ditch system that was judged to be as part of waters of the US. So if I'm off base there, you can say so, call me out, but that was the discussion I had with the Army Corps. It's going to be dependent upon each project on the size of the ditch and where it's connected to waters of the US, whether or not it's going to be deemed needed permits to move that ditch. So I will say in some cases, you should be able to do what you're saying there. You can move it. But in some cases, like the experience you had, you may not be able to do that without a serious permit and some additional sort of works of easement improvement on top of that. See one more question there, Clark.
Yeah, this is a pretty quick one. These
Okay.
would eventually fall under Ohio Revised Code 6131, the maintenance code for continuous funding.
Well, not 6131. That's the petition code. To be
Right, 6137, correct?
6137, I believe. That's correct. So yes, so that's what I mean when I say the finished projects through this grant, they must be placed on the maintenance program through 6137, and that's where the assessments would come into play for future maintenance. So that, yes.
All right, that's all the questions we have right now. We'll come back and look for questions again at the end if we have time. But Justin, if you want to go ahead and continue. Okay.
So John, if you're on the call, I will stop sharing my screen here, and I hopefully you can share yours if you've got slides or your screen, whichever one you want.
All right, thanks, Justin. Well done on the presentation there. Justin asked me to maybe share a few lessons learned over the years. He maybe already covered this already a little bit. You can do one side construction. I don't think it's ideal to try and get that inset pilot channel, with some bench on either side. I really think will help with stability. But if you do go ahead with a one side construction, we would recommend just making sure that that bench is 2 times the bank full width. So don't cut the bench width in half just because you're doing a one side construction. Sometimes you may not have an agreeable landowner that doesn't want to do the other side, or you may get, trees which make it cost prohibitive to, to remove all of that. But I can say if you have bank stability issues and you don't put a bench on that side, even if you do put it on the other side, there could still be some problems. So try to do the 2-sided construction whenever possible. But if you do go ahead with one-sided, make sure you keep the 2 times bank full width bench on the other side. Take into account your spoil distribution. We're trying to do some research right now to see, what are the benefits or impacts of spreading that on the field. I do know if you spread that right next to the ditch, making sure that there's a way for that surface water to drain down into the ditch is important. So think about your spoil management while you're doing all this. Some folks may not want that, spread out too far. So in worst case scenario, some of it may be trucked, which greatly increases costs. We have found that in ditches with very small drainage areas and very low slopes that don't have very much energy, they may tend to be more of a wetland system, especially if vegetation gets in there real thick. So if you're in a low drainage area, sort of low slope situation, we have looked at hundreds of these ditches where we can determine which ones become more wetlandy in a grade versus a 2-stage ditch, which becomes more of a self-flushing system over time. If you're on that low energy side of things, maybe we can help look at that, but it's possible in that situation you could end up with a wetland versus that compound 2-stage channel that becomes self-flushing. Another area where we've seen some issues where maybe the benches won't form very well is if you do have a high base flow. This is a ditch up in Marion County. It actually did have enough width to create benches, but there was constantly a high base flow, so it didn't allow that vegetation to come in to start narrowing up that channel, providing the roughness on the benches to get the sedimentation. So where you do have really high base flow, even if you have enough width, it may be questionable whether or not that two-stage system will form. Tile outlets, if you have a tile outlet that comes out in a bench, it's pretty low in the ditch. As long as you have that compound channel that keeps the outlet depth, keeps that fast, deeper water flowing, keeps the outlet depth good, I think you can outlet tiles through a bench. Where I'd be a little more wary is where it comes out right at the bottom of a ditch. I would really recommend against maybe doing one of the self-forming channels, because you really couldn't control where the sediment deposition is going to be, more likely to clog it. So, having the tile outlet onto a bench or through a bench in a two-stage system, I think that'll still work, but I'd be a little cautious about where it meets right at the bottom of the ditch. You may have to lower grade a bit in that sort of scenario. See, here's an example where we've kind of got a trapezoidal on one side and then the bench on the opposite side. Your riprap aprons, those sorts of things. But I can say, don't let your pipe outlet too far. It can cause some turbulence, some erosion in some areas. And if that water can outlet, even if it's onto an apron, if it flows through this little, this bench, this buffer strip at the bottom, some of the early research shows that there's a huge water quality benefit for letting this flow go through those benches. Really high nitrate removal, and then we think some phosphorus removal as well. So on your designs, try not to make them, too obtrusive where you're going to cause turbulence and some erosion and scour. Also know what your layers is, what layers of soil you have. In this particular case, this was a project in Indiana. And when they widened out the benches, they exposed this gray clay layer. And when it got saturated, it just fell apart. It just eroded away. Now, in the time since, it almost became a self-forming in that case, where it was constructed as a two-stage, the bench washed away, and then over time, deposition has occurred and those benches have reformed. But all of that erosion could have been avoided. So if there's any layers you're concerned about being resistant to the flow while the vegetation gets established, that might be a concern. And if it is a concern, you might need some sort of erosion control to deal with that. The other big thing we see is that uncontrolled water flow over the side, getting real erosion, gully erosion. So make sure you've got a good plan for getting water from the field edge down to the bottom of the ditch without overflowing uncontrolled on the banks. And then I think Justin mentioned this earlier, where you do, and some of the tools we have, we can predict these flow velocities. Where you do have high flow velocities, often on the outer side of a bend, perhaps you need to provide some erosion control, some riprap. One of the biggest things we can do is get that vegetation established really well, so it's got a layer of armor on it to keep it in place, to keep it from unraveling. The other thing is, a lot of times when you're constructing, if you have small little benches that have been deposited, so you're already getting these benches forming, during the construction process, we usually try not to remove that vegetation, because if these are deposited silts and sands, you can just destabilize those, and those will go downstream. They'll probably rebuild, but what that does sometimes is, when you get higher flows, you have more roughness along the channel margin, and it can push some of the flow out onto the bench. So hopefully those flow velocities up here aren't going to be too high. If they are, think about your erosion control. Justin already touched on this, your CRP buffer rules. If you're widening the ditch, you'll need to work through the issue of whether or not, you need to extend the buffer, whether you can even extend it. So just be aware of other programs that bordering the ditches that you're enrolling in. And I think one of the best things we can do, just make sure you're doing good vegetation establishment practices. Getting that good layer of vegetation on there is just really important for protecting that. Getting those compound channel hydraulics where you're getting the fast flowing water in the inset channel that's going to, scour the bed and keep that clear. And then the slower moving water up on the benches where you can get slow water treatment of the nitrates, deposition of a little bit of sediment, and some of the soluble phosphorus adhering to those soils. This was probably the biggest two-stage ditch project I've ever seen. It's up in Minnesota. It was on a huge drainage area. They decided to make the benches wide enough to get equipment down there. And, just concerned, I like projects that are in smaller drainage areas, shallower ditches that you can maintain with normal equipment. But if you can't get down there to mow, maybe you can spot spray. If you're worried about, future dip outs or other types of maintenance, there may be an upper limit to where you feel comfortable, and that's fine. Like I said, I think the most cost-effective projects are going to be on your smaller types of streams and easier to do that sort of work. Justin, do we have time to look at the spreadsheet real quick, or do we need to move along?
You got till 3 o'clock. It's all yours, John, whatever you think you can fit in.
So I know a lot of you are really comfortable in AutoCAD, or you have other programs you're making some of these design calculations in. We have another one. I'm just gonna go through the highlights today. If you're looking to do some of the ditch design and calculate earthwork, and you want to have some flexibility to look at how much earthwork there is with different bench heights or bench widths, Justin gave the example of 4 today, but this tool will help you run through, well, how much earthwork is there if there's a 3-to-1 bench ratio or a 5-to-1. So it's got a couple of tabs at the bottom. We got an instruction page. My colleague Dan Mecklenburg, who used to be with ODNR and now he's at Ohio State, has written a lot of this. Couple of simple inputs. You just pick what units. I suspect you're going to work in English units here. We need a drainage area that you can get from somewhere like Stream Stats. You can put in some details, what watershed, what's the name of your ditch. If you want to put some coordinates and those sort of things, those will translate to the outputs. You can do a couple of survey types. If you want to do like a profile type leveling survey where you have stationing, from the top to bottom, and then you have distances and elevations at cross sections, you can add that. Or if you're out there with GPS and you're getting something in state plane coordinates, you can choose the coordinates. That's the example I have here today. And then we have our design types. Do you want to do the bench? Do you want to do the two-stage? Do you want to do the self-forming? So you can pick which design you want, or you can just toggle between the two. How much earthwork is it if I do a two-stage? How much earthwork is it if I do a self-forming? Here's some of the inputs, that regional curve that Justin was talking about. So this example I've got here today, this is for something we did for some folks down in Arkansas. And they had a little grant program down there. So they had much wider, their inset channels were much wider. In our case, it was 6.9 to the 0.42 drainage area. So this is where you would put those curves, or we have some pull down menus if you want the Northwest Ohio curve or the Eastern US. So we have some pre-populated regional curves, but this is where you would put those regional curve numbers that are in the application that Justin shared with you. The other thing you can do is if you want to look at if you want to go ahead and calculate the at a station open channel hydraulics, you can put in anywhere from the 10 to the 100-year flows. We oftentimes use Stream Stats. Justin, had suggested another method today. So you can just put those hydrology calculations there. And then we have our survey page. Each survey page can hold up to 12 cross sections. You can cut and paste this up to 4 times, so it'll hold up to 48 cross sections. If you copy and paste this sheet, it automatically links them. So it's nice and simple. And then what you have is you basically paste in your survey coordinates and elevations. And then it will plot the existing ground. And based on whatever design criteria you've put in there, it will come up with the proposed cross section. So in this case, we have a 2-stage design. We actually have this set up so that you can have the bank. We want the user to be able to change. Maybe they want to build a 2-stage, but they don't want to build it to the endpoint. Maybe they only want to build it to half the endpoint so they can trap a few more nutrients, those sort of things. So we've actually got little sliders here that allow you to go ahead and change that on the fly. We can also change the bench width ratios here. So if you want to make wider benches, this is 3:1. So our inset channel is about 1 width, and then you have 1 on either side. But if I want to see what it looks like for a 4x design, all we have to do, use the little slider and it'll make the benches wider. So pretty user friendly. Once we get there, it'll go ahead, it'll take all your cross sections. It'll plot the lowest point for your profile. So you'll get an existing bed. You can actually, if you want to lower the bed in your design, there's a way to do that on our design tab. So it'll give you the bench elevations through there, the existing bed elevation. If you have a proposed elevation, these little triangles are every cross section that we have. And then it'll also plot the top of the ditch as well. It'll give you a typical cross section. And then it will go ahead and automatically calculate the earthwork volume. So as I make the benches lower, higher, I make them wider or narrower, the earthwork volume will update quickly. You can adjust channel side slope, so it's set 2:1. If you think 2.5:1 or 3:1 is better for your county, you can just go ahead, change the side slopes. So you have control over all parts of your design, how high or how wide the benches are, what your side slopes are, all those sorts of things. We also have a hydraulics page where it'll calculate the return interval of different flows. How much will your ditch hold? We use Manning's equation for that. So you can say if your existing channel is, bare soils, maybe your bench and side slopes, in this case, they're vegetated, but maybe you want to look at what the flow velocities are as constructed. So bare soils. So you can go ahead, that'll update, and then your mean velocities will update as part of it. So you can go ahead and do your hydraulics, look at shear stresses, look at flow velocities, see if you're getting in the range where maybe you do need some erosion control. Or you can see how that changes if it's all vegetated, what's my carrying capacity going to be during that, vegetated, unmowed sort of condition. And then lastly, we have our drawings page. We've actually had county surveyors and county engineers, drainage engineers in other states just print out these drawings, give them to the contractor, and then they'll have their cross sections at each of the stations. And over here, they have just a typical cross section. So like I said, this is a very big ditch further down south where their flows are less dominated by tile flows, and we get these narrower channels up here. They get very wide channels. So don't get scared about those numbers there. It's typically going to be much smaller in kind of our Northwest Ohio scenario. So if anybody has any interest in learning more about this tool, we can probably get through it in about, 2, 3, 4 hours. It's pretty simple. I teach my students in class in the course of 2 lab periods. And by the time of the second class period, they've done a design, these 18-year-olds. So you folks that have a lot of experience designing channels, I think you'll pick up on this real quick. If it's a tool that's maybe easier for you to use than, some of the AutoCADs or those sort of things out there, we'd be happy to help. Let Justin or I know, and we can do a little workshop for you. Was there any questions about that tool before I move on?
There are no questions in the chat. Does anybody have a question they want to ask verbally?
All right, great. Great. And the last thing I'd like to throw out there is this is a pretty significant investment of public dollars. And, we want to help where there's problems for the farmer or landowner. And certainly this can help address some stability, some flooding sorts of issues, but we're also trying to help document what's that benefit to society. How do we improve water quality? Issues on maintenance, those sort of things. So we were fortunate to receive a grant from the Harmful Algal Bloom Research Initiative, and it was really tied to having this program. So it's really nice when somebody's going to build one, we can do research from day one or even before day one. So one of the things we're going to want to do is document the water quality benefits. One way we'll do that is after construction, we will go out and we'd like to If the landowner is willing, if we could do surveys, monument some cross sections, and look at the sediment deposition and then the formation of that two-stage over time, take some soil samples, see how much phosphorus, how much nitrogen, how much carbon is trapped in those benches. But the other thing we'd like to do, and is going to require a fair amount of cooperation, is go out and use these automatic water samplers. So they basically have little bubblers in the end. It can tell how much water flows by, and every so many thousands of gallons of water, it's going to take a sample and put it in a bottle, and then we'll take it to the lab and we'll see if it has reduced the amount of soluble phosphorus. So through this program, what we're really looking for is some reaches that are going to be undisturbed, very close to reaches that are going to have a two-stage project put on them. And what the type of study we're doing is called before-after controlled impact. Oops. So what we'd like to do is for a year, maybe 15, 20 storms, before any changes have been made to the ditch, we'd like to sample upstream and then downstream of what we call a control reach. The control reach is where no changes will occur. And then we will monitor at the top and the bottom of where a two-stage or self-forming channel is going to go. So we'll do that. We'll get 15, 20 storms, and we'll see how the water quality changes through each of those reaches. Then what we'd like to see is then in maybe year 2, after that project is put there, that two-stage, that wider, we will continue to monitor between the upstream and downstream of the control reach, and then the upstream and the downstream of the treatment reach. And then what we'll do is we'll compare the differences. So that sort of experimental design will tell us, was there any benefit to implementing this practice? And if so, how big was it? How much did we improve or not water quality? So if there's anybody's projects out there, landowners that are asking the question, is this, we want to answer the question, is it worthwhile? Because if it's not, we don't want to continue to invest more and more dollars. There's a lot of research out there that suggests it is beneficial, but there's been very few instances of where the actual water was monitored. It's more researching what's been trapped here and assuming whatever's trapped there hasn't gone downstream. So keep in mind, if you have projects and you might have willing landowners, please help us maybe establish some research sites so we can make sure good investments are being made with public dollars. That's all I have. If there's any questions, I'd entertain those. Otherwise, I think we may be finished on time or a little early.
The only thing I'll add to that for the group, John, is the way we'll probably try to handle the research part of this. Like I said, that there is no requirement for any of these projects to be under the research, but we certainly want to partner with OSU and do this as best we can. The way we'll probably approach it is as the applications come in, before the approval of the application, we'll probably work one-on-one with the applicant to say, hey, this project might actually be a good site to do some research. Do you mind if we partner with OSU to get that installed? And so it'll be kind of a voluntary basis, but it'll also, if there are some kind of rankings where it's one ditch versus the other, depending on what we can fund, certainly the ones where we can get the research on, it's going to be the one that's going to be a higher value for us. So just understand that we'll work with you through the process, and we'll try to get this imposed on the ditches if possible as we go through. So that's the only thing I want to add to that part. Other than that, I don't see any other questions in the chat, unless I miss any, Clark, but.
No, all the questions have been addressed, and there's
Okay.
no more coming in at this time.
Okay. Well, I'll end by saying that, again, our goal is to make this program easy. We are paying for ditches. And anytime those of you that go through the petition process and go through the assessment process in particular, you understand that taking money out of the watershed can be a difficult thing when it's for the drainage improvement. So if nothing else, we certainly intend that this should ease some of those burdens, but certainly you're going to have other work throughs you're going to need to do, sell the concept of the two-stage ditch. So if there's anything else you need on information on the application form or two-stage ditch design, whatever, go ahead and contact me first. We'll see if we can get you pointed in the right direction, and hopefully over the next couple months, get several applications in for this program. So with that, unless anyone wants to voice a question verbally, we'll go ahead and end this webinar, and I appreciate all of you for attending and hope to hear from you soon.